Welcome, everyone. Today we're going to talk about how to make the good old Hibernate ORM world work with Elasticsearch. So my name is Emmanuel Bernard. I work in the Hibernate team, really, for quite a while. I've been working with them for quite a while. And I'm generally platform architect for everything data inside Red Hat middleware.
Okay, welcome. I'm David Pilato. I'm developer at Elastic, the company behind Elasticsearch and other tools, and I'm working specifically on Elasticsearch itself. That's all.
Okay. So Hibernate, you know probably the object relational mapper, otherwise I'm not sure why you're here. But it's really an ecosystem of things, different projects that address different issues. And Hibernate Search tries to fix the problem of being able to create an inverted index on top of from an object. And we've got different sources of object being changed, and Hibernate ORM is one of those sources. And we have different ways to index information. The main historical approach is Lucene, and now we have the Elasticsearch one.
So what is Elasticsearch? Elasticsearch is basically a search engine built in Java on top of Lucene, and it speaks JSON over HTTP. So basically, you can use that whatever your technology stack is, and yeah, really easy.
Cool.
So, in action now.
Yeah.
Already.
So we've got the code of what we're going to run here, and we're going to show the QR code a bit later. Anyway, whoops,
H.
Yes. You saw the future. There you go.
So we built an application, which is a demo here, and we are using some tests to run our application. So I'm just going to run the test to check that everything is working fine. Okay, so we have tests.
So that's a demo without Elasticsearch, without Hibernate Search.
Yeah. So the object we are going to manipulate today are video games. So in this entity video game, we have some fields like a title here, description, and so on. We have an inner object named publisher. If I go to the publisher, I have the name and the address and so on. I have a collection of tags for this video game and also a collection of characters for this video game. I'm sorry. And if I look at the test we have now, at the beginning, so we are using here Hibernate, obviously. The first thing we are doing is to create our data set. So within a transaction, we are building a first publisher for the video games, and then 3 characters, Luigi, Frank, and Dash here. All those characters are persisted. And we are creating the first video game. So this video game has this title, Revenge of the Samurai, a description, rating, and so on. This publisher, the one we have defined before. And also 2 characters here, Luigi and Dash, and some tags. Then we persist this first video game. We persist a second one here, Tanaka's Return, and a third one. And then, in our test, what we are showing is that we can create a query using Hibernate here. I want to query, and I'm looking for a video game where the title of the video game is the title I'm passing as a parameter here. So here I'm searching for this exact string, which is Revenge of the Samurai. I'm expecting to get some results. I'm expecting to get one result where the title is exactly Revenge of the Samurai. So this is the first test on a single field, single term. Here, just a bit more tricky. We want to search for only one subterm within the title. So we are using here a like % search, right, with %samurai %. And we obviously check that it's
So welcome
working.
full scan, right?
Yes.
Table full scan or hopefully index full scan.
Yeah,
right?
here we have 3 video games, so that will work. But obviously, if you have millions of video games, that will become an issue for sure. And then I'm searching here for 2 terms, so revenge and samurai. Obviously, it's working. But if I'm searching for the same term, but inverted, so samurai and revenge, then it won't work.
Same if you had capital S not capital S, you
yes,
probably would have
it will fail.
not have it.
Exactly.
Yeah, the other way around.
I'm sorry. So we want to switch to Elasticsearch, and to do that we can do that manually, actually. So I'm going to switch on a branch where everything is already written. I'm just going to explain what we did in that branch. First of all, we added Elasticsearch library, so the client for Elasticsearch. And also we are adding here Jackson library. Jackson will help us to transform our bins to JSON documents because Elasticsearch only speaks JSON, so you have to send to Elasticsearch JSON documents. If we look at the test class again, first of all, we are building our mapper, our Jackson mapper, so the mapper which will help us to transform JSON to bins and bins to JSON. And we are building a Elasticsearch client. So here we are using a transport client. And this client will connect to Elasticsearch, which is running locally here in a Docker container on this address. And this is the default transport port we are using. So this transport port is used by Elasticsearch to communicate between nodes. And the client we are using today is using that port. So what changed? So within our transaction here, we are still persisting some video games. Oh, I forgot to explain some annotation. No, after. So within the transaction, we are going to, just after we have persisted the first video game, we are going to call Elasticsearch with the client, and we want to prepare an index operation. We are going to index our document in an index named video game. This is the type of our documents and the ID of the document itself. Then we are writing this document as a JSON document using here Jackson. So we basically serialize this bin to JSON document, and we set that source to Elasticsearch.
Okay, so if you got an exception here, you swallow it, right?
Yes. So what you can do here is maybe to roll back the current transaction if you have any.
Okay.
Or you can just here print whatever you want to your ops team.
Yeah.
Because
send
here
him an email. Oops.
Yes, send an email. Because here I just want to persist in the database whatever is happening with the search engine.
But then if you... So if that passes, okay, so the first video game is persisted, then you index it. Then the second video game is trying to be persisted, and then there is a failure, which means the relational transaction is rolled back. So no game is stored. What happens?
So in Elasticsearch is not a transactional system, so you can't roll back what you have indexed. So if you have sent an index operation into Elasticsearch, it's too late, you can't roll back. So you have to deal that by yourself. Maybe crash everything and reindex everything, I don't know. Then same
Hopefully
thing.
No.
Sorry?
Hopefully no.
Same thing for the third video game here, we index exactly as we have seen before.
Okay.
We change a few things. So in the character here object, I had to add this JSON in here for Jackson. If I don't do that, when Jackson will try to generate the JSON document, it will go through an infinite loop because the video games, the character appears in a video game, and a video game has a collection of characters, and so on and so forth. So I have to ignore that field here.
Okay. And if remember when you saved the video game and also updated the index? So what happens if I change a character? Do I have to reindex the video game manually somehow?
Oh yeah, so probably you have to detect that in your service layer and then read again the video game from the database and send an operation into Elasticsearch to reindex the video game again. It's not automatic, right? Yeah. So that's it. And then the search part itself, I forgot to run the test to make sure that everything works. Okay. So what I'm doing here, instead of calling Hibernate here, I'm using now Elasticsearch client. So I'm running a search operation on index video game. And I'm using here a match query on the field title. I'm searching for Revenge of the Samurai. Then I'm executing this. and I'm getting back a response from Elasticsearch. And from this response, I'm going to iterate over the results. And for each result, I'm going to read the source document, which has been stored into Elasticsearch. And with Jackson, I will convert it back as a video game again.
Okay, so this is not a managed object by Hibernate, right? So if I modify it or if I navigate down, it might not have the objects I expect.
Yes,
correct?
it's a pure bin here, not managed one.
Okay.
So what you can do here, you can get, instead of that, the ID of the document, and then call Hibernate, just a line after that, and read the database again using Hibernate with this ID. This is what you can do here. So we check that everything is working well. Same for the other things. The cool thing now that we have a video, we have a search engine, is that even if I search for the inverted term, for Samurai Revenge instead of Revenge of Samurai, then this will obviously work if the tests are passing. Did we start the Docker? Yeah.
Don't worry.
Okay.
I don't crash my demos usually.
So this is what we did here.
Okay. I know there is the notion of analyzers in Elasticsearch, so you can select which analyzer to use for which field.
Yes, so you can define that. So to do that, you have to build what we call some settings and a mapping for the entity you are playing with. To do that, you have just to send a curl request to push your mapping. And as an example, I can show you here what the mapping is looking like. Here, so for example, here the mapping that Elasticsearch auto-guessed is like this. So you have a set of properties, and here you can define the analyzer if you want.
So what do? If I want to customize things, I maintain this JSON file on my code base or something.
Within your code base, you add this as a resource. But then anytime you want to obviously add a field or modify some properties of your mapping, then you have to adjust this file. You have to think about it.
Okay.
But you are always saying me that it's a bit complicated. Do you have a better idea to solve all that?
Yeah, I think I have the solution.
Okay. Your turn then.
Yeah, sorry, I've been nasty to him, but I like him, don't worry. So what I will do is go back to the legacy branch. Actually, I'm going to go a little step further and go in already pre-configured one. So I'll show you very quickly the POM. Here I've added Hibernate Search and two bits. The one that says, please listen to Hibernate ORM and notify me of every change that's happening when Hibernate ORM does something. And the other one that says, hey, please use Elasticsearch as the backend, the code that does that. And I use version beta 3. The candidate release is going to happen within a month maximum. We worked quite a lot in the last few months to really get something very good and running. And the second thing is to configure some things. And just like Hibernate, everything is configured either in your persistence.xml, hibernate.cfg.xml, your whatever Spring files or whatever. So the first thing is I'm deciding to use Elasticsearch as the index manager. The second thing is I'm pointing to the actual Elasticsearch
instance
node. Yeah.
Here you are using the REST port, right?
Yes, because we didn't want to be tied to one specific version of Elasticsearch, so we use pure REST calls, and we don't have a dependency on your library.
Okay, so we just released a new client for Elasticsearch 5.0, which is REST-based, but for now it's a too low-level client. So we are going to enhance that in the future, and then you will be able to switch to this official client probably.
Right. And finally, because we've got the classes, and classes have properties with types, and we can put annotations on that, we actually have all the information we need to actually create what we call the mapping file for Elasticsearch. So we can create it and push it to Elasticsearch.
You can drop existing data as well?
Yes, it's up to you. So this one wouldn't drop the data, but you can recreate that will drop the data. We've got a merge strategy which tries to, if you do a change, to also update the index as long as it's compatible, and so on. So next is to actually decide which entity needs to be indexed. So entities are not actually indexed by default, so I need to add indexed. And then I've decided which field I want to index. I don't want to index all of them. So I'm going to index a type. Ooh, what's going on?
You are using VI.
Yeah, I know.
description.
Description.
So can you set an analyzer for this field, for example?
Yes. So I say analyzer and defining the analyzer.
The English one, please.
You want the English one?
Yes.
And what's happening here is that the definition is the one that we will ask Elasticsearch to use, and Elasticsearch happens to have an English analyzer, so we propagate that.
So you can do that for numerical values as well?
Absolutely,
dates.
that would work. Dates as well, but we don't need it here. And this one is interesting. So that's another object, an embedded object in this case. And by default, we don't index stuff, so you have to decide what to index. So here I want to index the name. But I want to embed that information. So it's denormalization, really. So when I index the video game, I will also index the publisher, and in this case, publisher.name. Okay? Same for collection. I can say indexed embedded and use the field stuff here. So that's a collection of basic types, but that also works for the
many-to-many.
Yeah, the many-to-many, the character thing.
So are you not going to have this infinite loop that we have discussed before?
No, well, I guess at some point we had in the code, but not anymore. So there are two reasons why we don't have it. First of all, because I don't embed video games in here, I don't propagate things. So I don't have the issue of you going like in loops. But even if I had added an add indexed embedded annotation here, Hibernate Search by default will look, and if it finds the same instance twice within a depth, it will stop. And you can configure that by setting an explicit path that you want to index and not everything. So there is a lot of freedom here. What I will do, however, is add the contained in, which solves another problem of yours.
Yes.
So because of that information, when I received a character change event from Hibernate, Hibernate Search said, hey, hold on a minute. Character is actually embedded inside video game. Let's go up, look at the video games, and upgrade them because the character has changed. Actually, only if the field properties have changed. If special power has changed, it's not a problem.
So, okay, our model is ready now?
Yep.
So I guess that in the service layer or here in our test, you have to implement the fact that you have to create an index, push the mapping, and then send the data to Elasticsearch?
Nope. Hibernate Search does all that for you. So what happens is the deep integration between ORM and Hibernate Search means that within a transaction, we see all the changes that are happening, and the ones that are involved either a contained in or an actual indexed entity, we put in a queue. The persists are happening inside the database, and when the transaction rolls back, then this queue is discarded. But if the transaction commits, we are like, okay, here is a bunch of stuff we need to index, and let's go and index them in batch. So we use the Elasticsearch batching approach, and boom, everything is indexed. So you don't have the problem of stuff partial indexed while the data is actually not there.
Okay, you have to fix now the search itself?
Yes, well, not fix it, but implement.
Use now the search engine.
Exactly. So there is a sub-interface full text entity manager which does expose the full text query capability, essentially. So I'll use that. And I'll also create what is called a query builder. So you've got two query approaches. One is to use the native Elasticsearch syntax, and the other one is to use the Hibernate Search higher level DSL, which stocks objects. So that's the one I will demonstrate first, and then we'll move to the other one. So I'm creating the query builder for the video game. Getting it?
Okay.
And now I'm ready to replace this. Oops. Sorry.
So it's not yet.
And the chair is coming.
Thank you.
So instead of having the create query, I'll just replace it with a create native query. Oh, no, not create native query. Create full text query. In which case, I can use the query builder inside this one. So query builder. So you did a keyword query on a specific field. So I'll use that title. I could use other fields, so I could compound stuff. So it's a very nicely scale as far as complexity of the query. And I want to match Samurai, Revenge, I forgot the capital, wrong order, but that will work. I will also say that I want to target video games, so only this index is actually used. And there is I'll suppress the warning here. It's something we'll fix in the next major version of Hibernate Search. So it's minor improvement, but that would break backward compatibility, so we won't do that. By the way, I think it should work.
Yeah, let's see.
Um,
And just a question here. You are getting back a list of video games directly,
Yes.
but those are entities coming from the database?
Exactly. Those are just like the objects you would have retrieved from a JPQL query. That's the one you retrieve. So video game, if it has a lazy association to the publishers, not publisher in this case, but the characters, then when I navigate, I'll get the characters and so on, right? If I change the video game, the change will be propagated.
So can you use here Elasticsearch query instead? So
Sure.
instead of the...
So I'm just replacing this part, and I'll say Elasticsearch queries, and I've got two options. The query string, which neither of us really enjoy as far as the language, so the JSON, which is a bit more full features, let's say.
Can you write a JSON document?
I cannot write a JSON document, but I can copy-paste the JSON document, so that's what I'm going to do here. And that will also return manage video games. We just happen to use the Elasticsearch native syntax.
Does it work?
Yeah. But first, before that, I'll do pagination. I'll say, hey, I only want to retrieve the first 10 results, just like Google. And that's very important to do pagination. Actually, Elasticsearch mandates that you do up to 10,000 results and not more by default. So we highly recommend you to use the pagination indeed.
Let's run it.
Yeah, and the other thing I can do is to say, hey, I don't want to retrieve all of that data. I just want to retrieve some of it. So I'll use a projection, just like you can do a projection in SQL, right? The select part. And here I'll say I just want the title. And
let's say that I want to get back the score.
Yes, the score is the relevancy of a result compared to another one. By default, the full-text search engine returns the most interesting results at the top, and it's a good, interesting metrics to compare the top to the next element. Maybe if the next element is like 10% in relevancy of the other one, maybe you don't want to expose it. And in this case, I'll also return the source, which happens to be the JSON document that we push to Elasticsearch. So Elasticsearch talks JSON. So we create a JSON document with the stuff we want to index and pass it along.
So it means here that we are not getting back managed entities?
Yeah.
So we are not getting back video games, technically?
Yeah, actually, we retrieve an array of objects.
So that's super handy, because if you just want to display the result for your users and you don't want to go back to the database, you just have to use projection for that, and you have everything?
Exactly.
Okay, cool.
The other stuff, we don't have time to show you that, but the query builder is actually very powerful, pretty close to the powerfulness of Elasticsearch, except for the aggregation at the moment. Range query, aggregation of Boolean queries, faceting, keyword, which is the classical full-text query. More like this actually doesn't work for Elasticsearch because we have a very specific algorithm, so need more work. Phrase query, we can do sorting, spatial query, and so on and so on. So that was just to show you how things work. So the gist of this presentation is, if you have a Hibernate ORM application and considering indexing the information inside Elasticsearch, go and look at the Hibernate Search integration. We've solved a lot of complex problem or annoying problem you would have to solve manually. So indexing is really transparent, and the query is at the object level instead of down to the Elasticsearch level, even though you can still do native Elasticsearch queries. And lots of more stuff like error handling, so giving you back doing a callback in case of error, so you can log to the sysadmin or whatnot. The mass indexer to initially load all of the data from your database and push it into Elasticsearch.
Without writing a line of code?
Just annotations.
Okay.
Faceting, geolocation, we already showed you that very quickly in the query builder.
And then once you have indexed data into Elasticsearch, you can use some of the nice goodies we have at Elastic. So for example, Kibana here, where you can navigate through your result and explore your data set and make sense of your data, basically, and scale out as well.
Cool. Thanks for being here. We've got 5 minutes for questions, so let's try and use it. Use that time. Yes?
Hi. Do you have a way to restrict the indexation for entities that are in a certain state?
Yeah.
I want only to publish to index published products.
Yeah, the question is, can I restrict the fact that the entity is indexed based on the state of the entity. For example, if I've got a blog and the status is deleted, I don't want that to be indexed. The answer is yes, we have that inside Hibernate Search. On the entity, you annotate it, and there is a method that should return, I want to be indexed or I do not want to be indexed.
Yeah.
Yes?
So are you doing proper two-phase commitment in Elasticsearch and in relation database?
Yeah. The question is, are we doing two-phase commit between Elasticsearch and the database? So there are two reasons why we don't do that. First of all, Elasticsearch is not XA compliant, so that would be a bit tough. Yeah, we could do last resource, I guess. The reason we don't do it is because we feel that if you lose the indexing, it's not as problematic as actually losing the database transaction. So you want, for example, your order to be committed into the database, and okay, well, there is a failure with the index. I can catch up a bit later because I've got the raw data. So that's the main reason we don't do the actual indexing as a two-phase commit. That being said, we can do two-phase commit between the fact that we want to index and push that change into a JMS queue, and from there, if you do the JMS queue with proper, non-delivered thing happening, you would be able to get guarantee that at some point you will get everything into the index. Another question?
On top there.
I didn't get the beginning of the question.
It is mandatory that the data must be in the database for this API.
That's a good question.
That's a good question.
So, Hibernate Search.
Can you repeat the question, maybe?
Yes. So the question is, does the data has to be in the database, or can I actually have it just in Elasticsearch? So let me tell you some things, and let's see if we can answer that question. So there is the stuff we've demonstrated here is the integration between ORM and Elasticsearch via Hibernate Search. So if you use Hibernate OGM, which exposes access to the NoSQL universe and not the relational universe, you would be able to say, I'm going to index this NoSQL data into Elasticsearch. So that's non-relational. So it's not exactly answering your question, but that's interesting. We've got also an Hibernate Search integration with Infinispan, for example. So we listen to the Infinispan event changes, and we do the indexation through that. And it's not in the main branch, but I actually wrote something that is kind of a manual way to say, here is an object change, and please, Hibernate Search, go and index that information. Because I wanted to use that in a universe where I just had a file system, and I didn't want the full database or whatnot. So I guess you could use that API, which is in a branch, to do what you're looking at. Or the alternative, if you really want to just use Elasticsearch, is to write an Hibernate OGM dialect for Elasticsearch to store the data in Hibernate OGM. In Elasticsearch via Hibernate OGM, and from there you'll be good to go. Depends a little bit on what you want to do after that, but that's as close as I can get from an answer. Maybe one last question. Yes?
Can you explain what happened when the Elasticsearch will be not available?
Will not what?
Will not be available.
Well, it doesn't work. So the question is, what happens if Elasticsearch is not available? First of all, there is lots of tools so that Elasticsearch can be available, like replications and so on. You can talk about that. But at the moment, from an Hibernate Search point of view, if we try to do the indexing and it fails, you've got this error handling API that will be triggered. And the error handling is actually a piece of code that you write yourself. So you could have a log to your sysadmin, or maybe a retry operation after 5 minutes inside your applications or something like that. We don't have a system where we actually physically queue things and then try them again. I guess we could, with the fact that Hibernate Search has a kind of a way to push stuff into JMS, but I haven't actually tried those kind of combination. So it could be interesting.
I think we're done. Yeah, time's up.
We're done. Okay,
Thank
time's
you.
up. Thank you, everyone. And if you have more questions, you can come down.
Here's some
And we got
stickers.
lots of stickers.
And stay to my session then about bits.